Today's video will be a review of some of the particular units that we've worked on during our distance learning. So the first problem here is dealing with exponential growth and the use of logarithms. And the question says, suppose you deposit $700 in an account paying 2.4% annual interest for 8 years. Find the value of the account if the money was compounded weekly, compounded continuously, and then how long it would take for this account to be worth $10,000. So first of all, for weekly, if you remember this, we would take the rate, which would be 0.024, and I would divide this by 52 since we're doing it weekly. I would add 1 to this because it's showing growth. It's going to be multiplied by 700. And then the particular power would be how many weeks there are in 52 years, which would be 52 times 8, which I believe is 416. So you would calculate that and get the amount that it's worth compounded weekly. So on your calculator, I would just put in 700, parentheses 1 plus 0.024 divided by 52, close that parenthesis, and then take that to the 52 times 18, or 8 power. And that would give you a total of $848.13. Now the next problem, compounding it continuously. Remember, continuously we use the natural log and use E. So our formula there is PERT. And I'm going to take 700, my beginning amount, times E to the RT power, 0.024 times 8 power. So using my calculator, it goes 700 second ln, which takes my e to the 0.024 times 8 power, and I get a total of $848.17. So just a small change there if compounded continuously. Now the next problem is, how long would this be worth? $10,000. How long would it take for that? And we'll do this continuously. So our equation would be 700 times e to the 0.024 times t, because we don't know how much time it will be, and we want this to be worth 10,000. So in solving this equation, we're going to divide both sides by 700. So those cancel. Easily cancel this. The 100 divided by 7 comes out to be about 14.286. I'm going to leave it to, or round it to. Then we need to solve this equation. Now at this point you might get stuck a little bit. Remember, when we get stuck we would always change the form. Now this is exponential form, so it would be log base e, which is ln, log base e of 14.286 would equal the power, which is 0.024t. And so to get that time, we would take the natural log of that 14.28, and I'm keeping the whole value in my calculator, and then dividing this by 0.024. Time would be about 110.8 years. So that would take quite a while for that investment to be worth $10,000. Next problem we're going to deal with is using statistics again. So here I've got scores on an algebra test. Very important that I'm going to arrange these in increasing order. So I'm just going to rewrite them over on this side in increasing order. starting with 31. And then my next one would be, there's no 40s, there's no 50s, there's a 62, a 68. I'm going to cancel these out here just so I make sure I don't miss anything. In the 70s, I have a 72, a 73, a 74. And then I've got a couple 80s. I have an 83, I have an 84, I have an 85. And then my 90s, I have a 94, a 96, and a 98. So in this case, I've got 3, 6, 9, 10, 12 numbers. So make sure there's 12 in my list, which there are. So I'm confident I can continue this work. So median, middle number. So if there are 12 numbers, there's not an exact middle, but it would be the median between 74 and 83. So if I would add those two numbers up and divide by 2, my median would be 78.5. The mode is the one that occurs most often. In this case, there's no repeats whatsoever. So in this case, there would be no mode. The mean, I would need to add up all these and then divide by how many numbers you have. Add them up, you get 920 divided by 12. This would be a mean of about 76.6 repeating, or 76.7 if we round to the nearest tenth. Range, remember, is the max minus the minimum. So I'm going to take 98 and subtract 31. So my range would be 67. First quartile is going to be the median of these 6. Now, if there was an actual median in this list, we would not count that. We would go above and below that. There are 6 of those, so again, it's the median of 68 and 72, which would be 70, would be your first quartile. Your upper quartile would be the median of these, so between 85 and 94. Which is 89.5. That would be your third quartile. Your IQR is the difference between those. So it would be 89.5 minus the 70, which would be 19.5. And then we would make a box and whisker plot. So on my box and whisker plot, I'm going to label it by 10s, 30, 40, 50, 60, 70, just keeping it consistent, scaling it by 10s. And then my box is going to go from my first quartile of 70 to my third quartile of 89.5. I'm going to put a line at the median, which is 78.5, about right there. And I'm going to go to my minimum, and I'm going to go to my maximum. So those are statistics there. All right, then one example of simplifying a rational expression, and this one is a multiplication problem. So if you remember, we're going to try to factor everything completely. So this first expression, I could take a 4 out. I'd be left with 2x minus 5, so greatest common factor. This bottom, it has no greatest common factor. It has 3 terms, and it's not a perfect square trinomial, so I'm going to use trial and error here. Please use trial and error. Don't use the grouping photomath method. So it would be x and x. Factors of 35 would be 5 and 7. So I'm going to have 7 and 5, and I need to have a positive 7 and a minus 5. This one the same scoop, no greatest common factor. There's 3 terms. I should be able to factor by trial and error, x and x. Got a positive 10, tells me both sides must be negative. And again, 2 and 5. Give me a product of 10 and will give me the negative 7 in the middle. On the bottom, greatest common factor, take a 4 out of that. So I'm left with x squared minus 4, which has 2 terms, and it is difference of squares. So it'd be x minus 2 and x plus 2. So just factor everything as completely as you can. Once it's factored completely, you can cross cancel. So the x minus 5s would cancel. You could cross cancel the 4s. And then you can also simplify. So these x minus 2s would cancel. Anything on the top and the bottom will cancel. And then what are you left with? You're left with 2x minus 5 on the top. And on the bottom you're left with x plus 7 times x minus 2. And that's a final answer there. So tomorrow, you'll be taking a summative assessment like this. There'll be 3 questions very, very similar to these. These are just a couple examples of what I might ask you to do. If you're concerned about this at all, I would have you consider recommending rewatching some of the videos, looking at some of your previous work that you've submitted, and make sure you're able to explain it as you work through it. So I should hear your voice going as you're working through the problem. For today, just a matter of preparing yourself to do this, and then I will make and publish those assessments tomorrow. Have a great day.